you for watching this video. So in this video, we'll do the 24th of November 2023 question paper, Physical Sciences paper 1. And this is the momentum. So let's go. They are saying a wooden trolley of mass 2.7 kilograms moves to the left at a constant velocity of 3 meters per second. A wooden bullet of 0.03 kg is fired horizontally from the left towards the trolley. See the diagram. So on this side, you have this trolley, wooden trolley that moves to the left at 3 meters per second. And this side, you have this bullet that is fired to the right towards the trolley. No problem. The bullet strikes the trolley and comes to rest inside the trolley in 0.02 seconds. So this bullet gets in contact with the trolley, it meets the trolley, or it collides with the trolley and comes to rest, which is, it stops inside the trolley in 0.02 seconds, right? No problem. The average net force exerted by the trolley on the bullet during this collision is 591 newtons. The bullet and trolley combination now moves to the right. See diagram 2. So fine, what is happening here? So we have this wooden block here, or wooden trolley, which is moving to the left at 3 meters per second and have the mass of 2.7 kilograms, right? And here we have a bullet that is fired to the right and have the mass of 0.03 kilograms, right? So they're saying now, this is moving to the left and this is moving to the right. So this and that, they collide such that the bullet is stuck inside the trolley, right? And it takes 0.02 seconds for that bullet to become stuck inside the trolley, right? No problem. And they're saying now, the average net force exerted by the bullet is 591 newtons. So, the average net force exerted by the trolley on the bullet is 591 newtons. The average net force the average net force exerted by the trolley on the bullet is 591 newtons. So that's the force exerted by the trolley on the bullet is 591 newtons. No problem. So the average net force exerted by the trolley on the bullet is 591 newtons. So, which is during that collision, when these two were colliding, right? The average net force exerted by the trolley, by the wooden block on the trolley is 591 newtons. No problem. The bullet trolley system now moves to the right. So, which means after these two combine, after these have come to a stop inside the bullet, they look like this, and the system moves to the right. That's what happens. Moves to the right. And they are together, right? They are stuck together. So if they move to the right, they move at the same speed. They move at the same velocity. Because they are a system now. It's like you inside the car. If the car is traveling at 100 kilometers per hour, you are also traveling at 100 kilometers per hour. Because you're inside the trolley. You're inside the car. So you're having the same inertia as the car. If that makes sense. Or you're moving the same, let's just say you have the same speed as the car. So now, if this bullet gets stuck inside this box, and the box and bullet combination both move to the right, which means they should be moving at the same velocity. No problem. They are saying now, ignore all frictional forces, frictional and rotational effects. So they want you to ignore frictional and rotational effects. So 4.1, they're saying write down the magnitude and the direction of the average net force that the bullet exerts on the trolley. So we heard that the average net force exerted by the trolley on the bullet is 591 newtons. right? So the trolley is going to this direction, to the left, right? So if you draw, just think about these two when they were colliding, right? If you think about them when they were colliding, if you look at this and say, this is the bullet, right? The free body diagram of the bullet, I'll say you have the weight and you have the force of the what? Of the wooden block, which is, I'll say, force of the block on the bullet. Right? So this is your bullet here. So what do you have? You have two forces, the force of gravity and the force, this direction. This is the free body diagram of the bullet during contact. What you have here, I'll say, is force. It's the force of the wooden block on the bullet. So this is the force applied by the wooden block on the bullet. So this is the free body diagram of the bullet. Then, if you look at the free body diagram of the block, here's the block here. The block have weight, have the normal force, and you have the force of what? You have the force of the bullet, right, on the block. No problem. So they told you that the average net force exerted by the trolley is 591 newtons. So which means the trolley is exerting 591 newtons on the block, right? So what does that mean? And this force, you can see, is going to the left. By Newton 3, the bullet will also exert the same equal force, right, which of 591, but to the right, which is the opposite direction. So the force exerted by the bullet on the block is 591 newtons, but to the right. And the force exerted by the block on the bullet is 591 to the left. So you know Newton 3. If object A exerts force on object B will simultaneously apply the same force, exert the same force of the same magnitude but in opposite direction. Right? So that's what happens. So now, to answer your 4.1, right? We say, okay, we know that they're asking write the magnitude and direction of the average net force that the bullet exerted on the trolley. The bullet exerted a net force of 591 newtons, right? And it is to the right. This is the direction, because if you're looking at the block here, here's the block. Here is the block. Is feeling this 591 force, but to the right because of the bullet. Done. Go to the next one, 4.2. What are they saying? They're saying calculate the magnitude of the velocity with which, they're saying calculate the magnitude of the velocity with which the bullet strikes the trolley. Right? They want you to calculate the magnitude of the velocity with which the bullet strikes the trolley. The thing is, you know that the block was moving at 3 meters per second, right? It was moving at 3 meters per second. And this one, you just knew its mass, but you didn't know what velocity it was traveling at. So what we're going to use now, because we want the velocity, we want the velocity of this before collision. We know that after collision, the bullet came to rest inside the trolley. So we know the final velocity of the bullet, right, was 0 meters per second because it came to rest. We know the mass of our bullet is 0.03 kilograms. That's the mass of what? Of our bullet. we know that the net force of this bullet is up to you now, your coordinate system. I will take, I'll say, okay, my coordinate system is looking like this. Positive up, positive to the right. The net force is in that direction, is to the left. So my net force here is equal to negative 591 newtons. Why is it negative? Because the force acting, the net force acting on this bullet is to the left, and I'm choosing my left to be negative. I'm choosing my left hand side to be negative. So my net force is 591 minus 591 newtons. Because I'm taking the right as positive and the left as negative. That's what I'm choosing to do. No problem. So what do? We know from the impulse momentum theory that F delta T result in change in momentum. So which means the average net force acting on an object on a given period of time will cause the change in momentum of an object. So this object had this momentum, this bullet had this momentum going to that side, right? But the net force due to the block, to the wooden block, is this one. It's what caused the momentum to change from whatever the momentum was to becoming zero, because the object went to zero, right? Its velocity went to zero, which means the momentum is zero. This momentum, this change in momentum is called by the average net force acting on our bullet over a given period of time, which was 0.02 seconds. So we know that our net force is minus 591, right? It's negative because it's to the left, because this is the force that caused the change in momentum. Because, like I said, your impulse momentum theorem is basically that an average net force acting on an object in a given period of time will cause the change in momentum of that object. Because look, your object, your bullet, was moving at this velocity, and due to the force of this net force caused by this wooden block, the object, its velocity went to zero, which is the momentum became zero. So net force times the time, which is 0.02, is equal to the change in momentum. What is the change in momentum? Okay, let me just clean this. So we say F delta T is equal to momentum final minus momentum initial, right? Which is F delta T, impulse, is equal to M Vf minus M Vi, right? Then we know F is minus 591. Like I said, you can see your average net force to the bullet is to the left, times the time 0.02 is equal to M. What is your M? Is 0.03 times the final velocity of 0, because it became at rest inside the bullet, minus 0.03 times the initial velocity. So what do we have? We have the answer to this, what let's punch it out, is minus 591 times 0.02. So this becomes minus 11.82 is equal to minus 0. Becomes 0. So you have minus 0.03 Vf divided by minus 0.03 divided by minus 0.03. Vf is equal to this divided by negative 0.03. You get that your final velocity is 394 meters per second. Actually, it's your initial velocity, because that's what you're looking for. Initial velocity. you're looking for this. This all went to 0. You're looking for your initial velocity. Your initial velocity is 394 meters per second. Well done. Go to the next one, which is 4.3. No problem. What are they saying? State the principle of conservation of linear momentum in words, right? You know that what this thing is saying that the total linear momentum before collision is equal to the total linear momentum after collision. So, what does it say? The principle of conservation of linear momentum, it says that in an isolated system, right, the total linear momentum before collision is equal to the total linear momentum after collision. Done. So the sum of your momentum before collision should be the sum of your momentum after collision. That's what this thing says. In an isolated system, the total linear momentum is conserved, which means that the total linear momentum before collision is equal to the total linear momentum after collision. It's the same thing. Done. We move on to 4.4. I don't think I have to write that down. Just that in an isolated system, the total linear momentum before collision is equal to the total linear momentum after collision. It's this thing here. It's the sum of momentum before collision is equal, in an isolated system, the sum of momentum before collision is equal to the sum of momentum after collision. Done. Then move to 4.4. Calculate the magnitude and the velocity of the bullet-trolley combination after collision. So they want us to calculate the final velocity of the bullet and trolley after collision. So we use this principle that we just stated. So which means the sum of momentum before collision, which is the momentum of bullet initially plus the momentum of a wooden block initially, is equal to the sum of bullet after collision plus the momentum of wooden block after collision, which is final. You know what this is? It's M1. So it's mass of the block times velocity, initial velocity of the block, of the bullet, sorry. This is the bullet, plus mass of the wooden block times the velocity, the initial velocity of the wooden block, is equal to this. What is this? This is the mass of the bullet times the final velocity of the wooden block, right? Plus mass of the wooden block times final velocity of the wooden block. This is the final velocity of the wooden block. No problem. But these two are the same because the bullet and the wooden block are combined. So, like I said, if you're inside the car, you and the car move at the same velocity. So the bullet is inside the box. So the wooden block and the bullet have the same velocity. So what that means? It means that these two guys, the final velocity for the bullet and the final velocity for the wooden block, are the same. So we have mass of the block times initial velocity of the block plus mass of the wooden block times initial velocity of the wooden block is equal to the mass of the block times final velocity of both of them, which is of, let's say, velocity of a system, maybe, or combination, plus mass of the wooden block times final velocity of the combination of the mass and the block system. Then you substitute from here. Mass of the block of the bullet is 0.03 times the velocity, which was 394, plus the mass of the wooden block. What is the mass of the wooden block? The mass of the wooden block is 2.7. What was the initial velocity? It was minus 3 meters per second because it was going to the left. Is equal to the mass of the wooden block of the bullet 0.03 times final velocity of the combination times the mass of the block, which is 2.7, times the velocity of the combination, the final velocity of the combination. Then you solve from here. Punch the left hand side, 0.03 times 394 plus 2.7 times minus 3. So this is 3.72 is equal to 0.03 plus 2.7, because these are like terms, so you can add them. So it's like 0.03x plus 0 plus 2.7x. It's the same stuff. This is the same. So these are like terms. So this is 2.73 final velocity of the combination. So divide by 2.73, divide by 2.73. You get that the final velocity of your combination is 3.72 divided by 2.73, which is 1.36 meters per second to the right. Done. That's what we have. Looks like that. I hope this work is clear to you as it is to me. Thank you for watching. Cheers.